Meet Charlotte the spider. She is crawling along a web shaped like a 5-pointed star. The web has 5 outer points, the sharp tips of the star, and 5 inner points where the lines of the star cross each other. Charlotte starts at one of the outer points and takes exactly 3 steps, each time moving to a randomly chosen neighboring point. The question: what is the probability she ends up at an outer point? Let's look at the structure of the web more carefully. The gold dots are the 5 outer points, labeled O0 through O4. The cyan dots are the 5 inner points, labeled I0 through I4. Each outer point connects only to its 2 neighboring inner points. So an outer point has exactly 2 neighbors. Each inner point connects to 2 outer points plus 2 adjacent inner points. So an inner point has exactly 4 neighbors. This asymmetry is the key to the whole problem. Now let's derive the transition probabilities. From an outer point, there are exactly 2 neighbors, both inner. So Charlotte always moves to an inner point with probability 1. From an inner point, there are 4 neighbors, 2 outer and 2 inner. Charlotte picks one uniformly at random. So she moves to an outer point with probability 1/2, and stays at an inner point with probability 1/2. Notice the beautiful symmetry. By the rotational symmetry of the star, it doesn't matter which specific outer or inner point Charlotte is at. All outer points behave identically, and all inner points behave identically. Here is the full question. Charlotte starts at an outer point and makes 3 random moves. What is the probability she is at an outer point after exactly 3 moves? The answer choices are A. 1/5, B. 1/4, C. 2/5, D. 1/2, E. 3/5. Let's solve this step by step. Step 1. The key insight. Track only outer vs inner. Because of the star's rotational symmetry, the exact point Charlotte is at doesn't matter, only whether she is at an outer or inner point. So we define P sub n as the probability of being at an outer point after n moves. The initial condition is P sub 0 equals 1. Since she starts at an outer point. In the right panel, watch 3 simulated random walks from the top outer point. The red path traces each possible 3-step journey. Step 2. Build the recurrence relation. To be at an outer point after n plus 1 moves, Charlotte must have been at an inner point after n moves. Since only inner points can lead outward, and then chosen one of the 2 outer neighbors out of 4 total. That gives us P sub n plus 1 equals 1/2 times open pareng 1 minus P sub n close pareng. The factor 1 minus P sub n is the probability of being at an inner point after n moves. The 1/2 comes from the probability of moving from inner to outer. Let's rewrite this as P sub n plus 1 equals 1/2 minus 1/2 P sub n. Step 3. Find the equilibrium and solve the recurrence. We look for a constant solution C where P sub n plus 1 equals P sub n equals C. Substituting C equals 1/2 minus 1/2 C. Solving gives C equals 1/3. Now substitute Q sub n equals P sub n minus 1/3. The recurrence for Q sub n becomes Q sub n plus 1 equals negative 1/2 times Q sub n. This is a simple geometric sequence with ratio negative 1/2. So Q sub n equals Q sub 0 times negative 1/2 to the power n. Since Q sub 0 equals P sub 0 minus 1/3 equals 1 minus 1/3 equals 2/3. We get the closed form. P sub n equals 1/3 plus 2/3 times negative 1/2 to the power n. Step 4. Verify each step. P sub 0 is to 1 over 3 plus 2 over 3 times negative 1 half to the 0 equals 1 over 3 plus 2 over 3 equals 1. Correct. P sub 1 is to 1 over 3 plus 2 over 3 times negative 1 half equals 1 over 3 minus 1 over 3 equals 0. This makes sense. After one step from an outer point, Charlotte is always at an inner point. P sub 2 is to 1 over 3 plus 2 over 3 times 1 quarter equals 1 over 3 plus 1 over 6 equals 1 over 2. P sub 3 is to 1 over 3 plus 2 over 3 times negative 1/8 equals 1 over 3 minus 1 over 12 equals 1 over 4. Step 5. The final computation. We plug n equals 3 into our closed form formula. P sub 3 equals 1/3 plus 2/3 times negative 1/2 cubed. Negative 1/2 cubed equals negative 1/8. 2/3 times negative 1/8 equals negative 1/12. So P sub 3 equals 1/3 minus 1/12. Finding a common denominator. 4/12 minus 1/12 equals 3/12, which simplifies to 1/4. The probability Charlotte is at an outer point after 3 moves is 1/4. The probability that Charlotte is at an outer point after 3 moves is 1/4. Which is answer choice B.